Hello everyone, my name is Chhich THAI and I'm come from Water Supply Company Ltd and working with my other two co-workers who are Panhavath and Sereykuchrainsey. So today I'm going to present to you about the water supply system project for Township Development Phase 2 project execution. So in this presentation, I'm going to cover these project timelines, which are the catchment modeling and demand management, town water supply system, and farm water supply system. So I'm going to briefly talk about the project brief. So there is a new township development that estimate to accommodate 500 households, 50 small business outlets, and several animal farms. So there will be a water reservoir located in existing valleys, and the water will be supplied to the township and farm through two separate water systems. And we will model the water catchment and the design of the two water supply system for the township and farm. So move on to the first part, which is the catchment modeling and demand management. So in this part, we are going to estimate and control the water in the reservoir, and here's the following are the design parameters. Like I mentioned earlier, there will be 500 households, 50 businesses, and there will be a minimum water storage of 1 million meter cubic in the reservoir during the 3-year periods. And also the final water volume in the reservoir must be no less than 2.5 million meter cubics. And the rainfall and the evapotranspiration data will be provided in the spreadsheet files during those 3-year periods to calculate for the available water. Moreover, during the site inspection, we also collect specimen of the soil to calculate the water content, and as well as the geotechnical and hydrological parameter of the catchment area also given. So move on to the water consumption for each household will be 500 liters per day and 700 liters per day respectively to each seasons. And water consumption for business outlet is estimated to approximately 1,000 liters per day throughout the whole year. Move on to the dairy farm, which is mostly water consumption of each cow. So first is each cow would need about 10,000 liters per year for general operational purposes, and 80 liters per day and 180 liters per day respectively to each season. Moreover, we also consider minor water need of each household, business outlet, and farm to estimate about 15% of the total daily consumption. So here's the spreadsheet for our catchment modeling and demand management to calculate for the water flow in and the water flow out, and in order to see how much water in our storage each day. And moreover, that after we calculate the water storage of each day, we also can find the water amount of cow as well, and which meet with our requirement, which are the minimum water storage to be larger than 1 million meter cubic, and the final water storage be no less than 2.5 million cubic. And we have come to a conclusion that our amount of cow would be approximately about 45,000 cows. So moving on. So for the next part, I would like Panhavath to explain more about it, which is the town water supply system.
So hello everyone. Now it's my turn to tell you about the town water supply system. So first, let's look about what are we going to do. For the task, it is for us to propose a cost-effective system to supply water from the water storage reservoir to the water tank and then to the water distribution tower. And also let's talk about the design parameter that has been given to us. First, the location of the pump station it will need to be determined, and then the shape, size, elevation of the water tower, and then the selection of the pipe diameter, and then the arrangement of the pump, and also the installation cost and other costs in general for all of our system and operation. And then next we will need to talk about the maintain water. And then we also need to maintain the water pressure of 400 kilopascal at the water distribution station, and the different elevation between the selected location of our water tower and our town is 15 meter, And then in case of any emergency happen along the way, we will need to maintain a 3 days of water usage in the tank. And also a straight line or pipeline route is established to go uphill 40 meters from the reservoir to the the water tower. The length of the pipeline is estimated to be 4 kilometers. And also they have also provided us with a water consumption chart. As you can see, the left is for household and the right is for business outlet. So now since the town water project is very big in scope, we have decided to divide it into two. First, let's talk about our first section is from the water tank to water distribution station. So what factor do we need to consider for this section? Well, as you can see from this image, we will need to determine the height of the water tower, the height of the water tank, the shape and the sizes, and also the pipe that will need to be connected from the tank to the water distribution station. So let's look at, here it is. These are the factors that we need to consider. And as you can see here, these are some of the products that we decided to choose for our determinants. So which one of them is the best? Let's take a look. As you can see here from this chart, you can see that at the green line, this is the most optimal dimension for both water tower, diameter, and also height of all our three products. And see here, the green line from the total cost, it is the most preferred out of every option here. And see here at the final, the most right table. So let's move on to the next part, which is water reservoir to the water tank. So what factor do we need to consider for this part? Well, unlike the previous part, for this part, we'll need to consider the pumps and the pipes. And here, the pumps will be our primary focus. And as you can see here, for our pump, we have decided to use the German RUPP brand name product, model T4A3SB. And as for the pipe, previously, we also used the same pipe, which is the UPG pipe, EO pipe. But for this one, the diameter is different from our water reservoir to the water tank, and it's different from the water tank to the water distribution station. So let's see how we decide to determine this factor. So as you can see here, from our pump setup, we have decided to put 4 pumps in parallel and 3 pumps in series, and it will give us a total of 12 pumps. Why did we decide to do this? Well, as you see here from the right, this configuration is the most perfect for our required height and discharge queue to supply our town. What do I mean? Well, let's take a look further here. And see here, the short line at the bottom is actually our original 1 pump performance curve. But here, this line up here is actually our new performance curve when we have arranged it into our series and parallel, which basically which is a 4 parallel and 3 series. And here, the slightly lighter blue line is our system curve. As you can see, only when we arrange it in this configuration will it intersect at this point. So this is basically why we have chose our configuration. So now let's take a look at our hourly water consumption distribution. Since we've known from our previous chart, our parameter chart, the water consumption is not based daily, but it's based around hourly. And as you can see here from this chart, the green one represent our water consumption hourly from April to October, and our slightly bluer gray line is from November and March. And the difference why they have different shape, because each different season the water consumption is different. And so basically what you can see here is that we need to make sure that our line stays in between these two limits, both the upper and the lower. The lower limit basically represent our three water emergency supply that we need to supply to the town in case of emergency. And the top line is basically our tank maximum capacity. So let's take a look at how we determine this. Here we have decided to, in some case, maybe some household might use more water than expected, and some household might use less. The same goes for business. So to determine that a steady rate of water is left in the water tank, we have applied the use of a water sensor by the brand of Vika, which is the model of RKL03. And see here, it has a pretty good range. It has the power output is pretty minimal, and also the price is not too expensive. And with this, it will help us to better control our water capacity in the tank. And here, the final one is our total expense report. As you can see, our system might be a little bit expensive, but the majority of the cost will come from the pumps and its operational cost, because our pumps power consumption per hour is around 22 kilowatts per pump, which is rather a little bit expensive, but rather show you it is quite safe. So next, let's move on to our farm water distribution system.
So my name is Sereykuchrainsey UN. I'm from the company of CU3, and I'm here to present you about the farm water supply system. And our task is to propose a cost-effective system to supply water from the water storage reservoirs to the farms. And our design parameter, the farm will be supplied from the reservoir each second day over a 2-hour period. The water will be delivered through a leading concrete open channel. The channel part has 2 straight sections. The first section is from reservoir, is 1.2 kilometer long with 4 meter deep in height, and the second part is 1.5 meter long with 1 meter drop in height. The cross sections of the main channels must have the same 100 millimeter thickness of their walls for their structural integrity, and must provide construction method for each open channel. And our design here is to make sure we reach the requirement to supply all these parameters for the farms. And here is the way that we design the water reservoirs that has the depth, the drop of 4 meter and the length of 1,200 meter. And here is the parameter that we use to design the open channel, and we use the parameter to calculate the flow rate in the second chart. And our first sections of design open channel here that has a total depth of 1.47 meter and the depth of 0.83 meter. And here the section 2 of our design open channel with the drop of 1 meter and the length of 1,500 meter. And here the design parameter that we use to calculate the flow rate. And the second we use of the open channel here with the total depth of 1.87 meter with the depth of 1.12 meter. And after we design here our total construction cost, which is embankment cost per tract, reinforced concrete cost, formwork cost, slice cost, and labor cost, and with the total cost of $896,629.76. So that's all about our presentation. Thank you for your attention.